Okay, class, at this point you should have out your assignment packets that Mr. Pazzi has handed out. That's this packet here. You should have out your notebooks ready to write in. And you should have out, of course, something to write with and a baby calculator or a calculator of your own if you have one. You do not need a scientific calculator today, so there's no need to get up and get one of the big ones. This will suffice for today. So calculator, your pencil or pen that you're using to take notes, your homework packets that were just handed out, and your notebooks. What we're going to start with first are the notes. So, notebooks out, if you will start to label. This is 8-3. There is no 8-2. It's 8-3 tangent lines. And today's date is the 18th. Now it's just a reminder that everybody should be in their assigned seats. Cell phones should be put away. You should be focused and ready and not chit-chatting with the people around you. All right, what is a tangent line? Not the tangent function. Yes, we've done SOHCAHTOA where tangent was opposite over adjacent. This is not the tangent function, it is a tangent line. Okay, a tangent line is obviously a line. It is a line that intersects the circle in exactly one point. All right, what does that mean? A tangent line, it is a line that intersects the circle in exactly one point. Okay, so let's draw our circle over on this side. And draw a radius. This is the center. The radius touches from the center to the edge of your circle. And at this point, I'm going to draw a line that touches that circle only at that point. Okay, that is a tangent line. The point at which they intersect is called the point of tangency. I'm not going to write that down, but just so you hear it, point of tangency. Okay, tangent line. Now, the reason I drew the radius is this is a special property that you will need to know for today's assignment. I'm going to write it down here. A line tangent to a circle. A line tangent to a circle. This is a line here that is tangent to the circle. All right, a line tangent to a circle is always, the upside down T means perpendicular. A line tangent to a circle is always perpendicular to the radius. At that point. So this is the point where the radius touches the circle. Then this tangent line at that same point will always be perpendicular to the radius. Important information. All right. Examples. All right, I'm going to put in parentheses here, lines that appear tangent are tangent. All right, so if it looks like, I can't tell if that's tangent or not, if they appear to be tangent, it is a tangent line. We will not have to specify on every single problem that's a tangent line. 1. On number 1, we're going to find x. Okay, let's draw our circle. Now I'm going to draw a diameter. Diameter goes from one endpoint to the other on a circle, but it also passes through the center. A point that passes to the center from one point to the other endpoint of the circle. All right, now I'm hoping everyone recognizes that yes, this is a diameter, but this piece right here is the radius, or that piece up there is the radius. All right, I'm going to draw a tangent line right at that point on the circle. There's my tangent line. And I'm going to connect it to this top point up here. So it looks like this. All right, I'm going to give you that this is 43 degrees. That will be given information. This is x degrees. That's what we're looking for, and that's all I'm going to give you. This is 43 and this is x. Now, if I did no explaining up here, and I just gave you this, you wouldn't have enough information. 43, I don't know this angle, so I cannot find x. But we just wrote up here a line tangent to a circle, and I just told you this line is tangent, and it looks tangent, and we said up here if it looks at tangent, it is. So this line is tangent to the radius. This is the radius. It is always perpendicular. So that is 90 degrees. Now, it didn't tell us that. It won't mark it there for us. We just need to know that. If I have a circle and a radius and a tangent line tangent to the circle at that point, it'll always be perpendicular to that radius. All right, so now we have enough to solve. X plus 90 plus 43 equals 180. I'm going to let you guys solve that now. Add your 90 plus your 43 and then subtract from 180. Go ahead and do that now. X equals 47 degrees. Okay, again, this was not given, just the stuff in the ink pen, 43 and x. We know this is perpendicular because this is a tangent line and that's the radius. And according to this information, they're always perpendicular to each other. So 90, 43, and x adds up to 180. Okay, number 2. Find the radius. Okay, here's your circle. Here's your center. We'll call the center P. I'm going to draw this line here. Remember, that is called the radius. I'm going to draw this line out here. And now I'm going to tell you right now that this line is tangent, but on the homework it's not going to tell you every single time. Again, for that reason here, if it appears to be tangent, it is. All right, and then I'm going to connect there. So go ahead and draw that center P. Circle at center P, and I'm going to give to you that the length of this leg is 12, the length of this leg here is 13. Find the radius. Can you see that this here is the radius and what I'm looking for? You can call it X, you can call it A, you can call it R for radius, call it what you'd like, but that is what we're looking for. All right, So how in the world am I going to solve for a side when all I know are these two sides and no angles? Remember, since this is tangent and this is the radius, they are perpendicular. So that will not be marked, you just need to know. And because it is a right triangle, we have a special formula to use. Can you remember what that special formula is? Good. I'm hoping everybody at least thought of using a squared plus b squared equals c squared, where c is your hypotenuse. Now, I've had kids ask, well, how do you know which one's the hypotenuse in this picture? It looks kind of wonky or funny. Two things. Well, one thing, the hypotenuse is always opposite the 90. So 13 is the hypotenuse. I will often have kids say, well, that up there looks like the hypotenuse. Yeah, it looks like it, but it's not. This here is not a 90. That's the angle that's 90. How do you know that's the one that's 90 and not the one here at the center? Because it's the tangent line with the radius. Tangent line perpendicular to the radius. So that's the 90, which means 13 is the hypotenuse. Okay, so 13 squared goes on this side. R squared plus 12 squared goes on the other side. R squared plus 12 squared equals 13 squared. I'm going to give you guys a few minutes to solve that now, or a few seconds. You don't need a few minutes. Go ahead and work it out. All right, I'm hoping everybody's at least this far. R squared equals 25. We square root both sides, and R ends up equaling 5. So the radius is 5. Okay, we are going to move on now to number 3. Number 3 is a little, it's not hard, it just has really big numbers, so it will require a lot of writing. If you're at the top of the page like me, or you're writing up against another problem, you leave enough room up here, draw your circle a little lower because we're going to draw stuff on top of the circle. So I'm going to put my circle here, leaving space here to draw the rest of the picture. Okay, here is the center. That is the radius, and since it's from the same center, well, there's only one center, out this way, that is also the radius. Would you agree? Radius, radius. Okay, I am going to continue this, and I'm going to connect it with the tangent line there. Okay, so I'm going to call this H, and I'm going to call this tangent line D. D for the tangent line, H for this segment here that's coming out of the circle, R and R for the radius. Okay, so everyone needs to have this picture down. And here is what's going to be given to you. You'll be asked to find D given H is 3 kilometers and R is 6,400. kilometers. And this is where the numbers get really big because of that number there. All right, so I'm going to redraw that triangle here. We know that because D is tangent, and I already told you it was, and you assume it is because of what we said earlier, that's 90. This is R. This is R, so that is 6,400. And I'm well aware that this is not drawn to scale. This is R, and this is H. So R is 6,400, and H is 3. 6,403, and I'm well aware it's not drawn to scale, but that is okay. If this is 6,400 and this is 3, what's the total length here of the hypotenuse? I'm going to repeat that. If this is 6,400 and this is 3, what's the total length of the hypotenuse? 6,403. And D is what we're looking for. A squared plus B squared equals C squared, where C is the hypotenuse opposite the 90. A squared, 6,400 squared, plus B squared, which is labeled D in this case, equals 6,403 squared. Okay, you will definitely want your calculators. All right, so you take your calculators out, turn them on, hit the clear button, and we're ready to type in 6,400 squared. 6,400 times 6,400 equals 40,960,000. All right, I'm going to write that big number down here. That was 40,960,000 plus D squared equals, next one, 6,403 squared. So I'm going to clear 6,403 times 6,403 equals 40,998,409. Now kids are thinking, oh, that's way too hard. You're not doing it by hand. Your calculator is doing all the hard work for you. All you're doing is writing it down, and that is the only piece that kids think is hard. It just takes a lot of time to write down all these numbers, but deal with it. Again, you're not doing the hard work. The calculator is doing the hard work for you. All right. We want to get D squared by itself, so I'm going to leave this number in your calculator. Do not clear it. If you've already cleared it, just put it back in quickly. 6,403 times 6,403. Leave it in your calculator. Put it off to the side. Take away 40,960,000. Take away 40,960,000. And that's what you're going to plug in your calculator. That top number should still be in there because I told you to leave it. Take away 40,960,000. 38,409. $38,409. And we're going to do what to both sides? Square root, and we're just going to plug that in our calculator and get a decimal answer. We're not going to break it down and take the pairs out. Leave this in your calculator, hopefully you still have it, and just hit your square root key, which is here, and let's round to 3 decimal, or you know what, let's do 3 decimal places. So that is D equals 195.0 0.982. Okay. Again, it's not hard. It just takes a lot of time to write all the numbers down, but we can handle that. Much better than having to do everything by hand. Number 4, determine whether a tangent line is shown. So this one is not, if it appears tangent, it is tangent. This one is asking us, is this a tangent line, yes or no? All right, A. Draw your circle. Center, radius. I'm going to call this radius 6. I'm going to draw what looks like a tangent line out. We're not sure if it is yet. I'm going to draw this line out. And I'm going to tell you that this leg here is 8. This leg here is 11. And the question is this a tangent line? Obviously that is not the tangent line. And that's the radius. So this is the only one that's possibly tangent. How can we tell if it is a tangent line? Think back to last unit when we asked questions about is it a right triangle. First off, I'm hoping everyone agrees that if it is a tangent line, it would be perpendicular to the radius. Don't write that down because I'm going to erase. And I'm working with pencil so I can do that. So I'm going to repeat it. If this is tangent, then it is perpendicular to the radius. So, if it is perpendicular, what formula should work? Correct, the Pythagorean's theorem. A squared plus b squared equals c squared. If it works, it is a right triangle, which means it is a tangent line. If it does not work, it's not a right triangle, which means it is not a tangent line. All right, how do I know where A, B, C? C is always the biggest, and it's always opposite the 90. Now, we don't know if this is 90 yet or not, but if this is the tangent line, this is where the 90 would go. So 11's the possible hypotenuse. So 6 squared plus 8 squared equals 11 squared. Go ahead and work it out. $36 plus 64 equals 121. 36 plus 64 is 100, which does not equal 121. That means no, it is not a tangent line. If you just put no, that is okay. No, it is not a tangent line. Why? Pythagorean's theorem did not work, which means this is not a right triangle, which means that is not 90. And since it is not 90, this line is not a tangent line. So you can't just say, oh, it looks like it's tangent, so yes. No, in this case, it is not. All right. Because of time, and I don't want to take up too much time in notes, I'm not going to do all of B. I'm just going to quickly review a concept. You'll need to know this for the homework today. How do I work out 5 root 3 squared? You'll need this in one of or a few of the problems tonight. 5 root 3 squared. So what if one of these legs up here were 5 root 3 and you're doing your Pythagorean's theorem? Remember, you do this. 5 root 3 times 5 root 3 equals 25 times, without saying 9, without writing 9, what's root 3 times root 3? 3. Or root 9, which is still 3. And 25 times 3 is 75. All right, again, I didn't do a whole problem like this because we're running out of time and I don't want to take up too much time on notes. I'm just quickly reviewing with you. When you're doing Pythagorean's theorem, if one of your legs come out to be a 5 root 3 or 6 root 2 and you're squaring, multiply the coefficients, and when you multiply the radicals, they undo each other. Root 3 times root 3 is just 3. All right, moving right along. Okay, draw your circle. Center is at Z. And I'm going to put a point out here, B. And we're going to write down if BA and BC are tangent. All right, if BA and BC are tangent, what happens? Okay, so I'm going to put some points on here. I'm going to call this one A, and B to A, that is a tangent line. Okay, so that is tangent, and that one is tangent. And this is going to be C. If BA and BC are tangent, so if you have two tangent lines on a circle and they intersect at the same point, like this point right here, if BA and BC are tangent to a circle, remember that's shorthand for circle. If BA and BC are tangent to a circle, then BA will be congruent to BC. All right, what does that mean? I always think of these as like a snow cone problem. These segments here will always be congruent if they are tangent and intersect here at the same point. All right, so let's try an example. I believe this is number 5. If not, oh well. Okay, draw your circle, and I suggest you draw it with me. Okay. From this point, I'm going to draw a tangent line here. And from this point, I'm going to draw a tangent line there. And I'm drawing more. This one I'm going to connect out. All right. So we have a few snow cones. You can see one there. You can see one there. There's the cone. And you can see a tiny itty bitty cone there. A cone, and the cone. All right. I am going to give you some information. I'm going to give you that this is 4.2. This is 6.7, and this is 1.9. And I'm going to ask you to let's write it here, find the perimeter. I'm asking you to find the perimeter. Okay, so remember what we said about this whole tangent lines at a point. So here's a point and these two tangent lines, which means that these two segments are congruent. These two segments are congruent, and these two segments are congruent. So congruent 1.9, congruent 4.2, and what would this long segment be equal to? 6.7. Cone, these lines are equal. Think of it as a snow cone. These pieces of your cone are congruent. Again, think of it as a snow cone, and these segments are congruent. So when you're looking for your perimeter, you're going to be adding up all the sides. I'm going to start here and go around. 6.7 plus 6.7 plus 1.9 plus 1.9 plus 4.2 plus 4.2. Again, kids will complain, but all you're having to do is write the numbers down and then plug them in your calculator. So go ahead and plug them in now. And your perimeter comes out to be 25.6. Again, the ones in blue were given. The ones in red we wrote down knowing that these two are congruent, these two are congruent, these two are congruent, and then add up all the sides. Okay, now that's it for notes, so I'm going to have you put this aside. We still have another lesson to get through. But before we get to that lesson, I want to give you some time to work on homework. So if you will please take your packets out. This packet here. If you will please take this packet out. I just want to quickly talk about a few of them. And then you can get to work. Okay. I will tell you right now, 1 and 2 are a little more difficult. I didn't do one exactly like this. Try your hardest. I want to see just what you can do on your own. So try, give them a shot, and if you can't, I will answer them next week. Number 3, this is one we did in notes. You should know how to do this one. Again, we know that this is tangent because it says here, if they appear to be tangent, they are. So if this is tangent, where does the 90 go? By the tangent and the radius. So 90, 36, find your x. All right, I do want to talk about this one here. This is that long, harder one that we did in notes that I said you guys just have to deal with. The circle at the right represents Earth. The radius of the Earth is about 6,400 kilometers. This is the radius of the Earth, radius of the Earth. Find the distance d to the horizon that a person can see on a clear day from each of the following heights above Earth. Round your answer to the nearest tenth of a kilometer. Okay, so this one says tenths. When our notes we did thousandths, so we'll just round to a smaller decimal. All right. So in this picture, this is D, and D is what we don't know. It says here, find the distance D. That's what we're looking for. The radius is 6,400. 6,400. Each of the following heights. This is the height here, and the height changes on each problem. So for number 4, the height is 7. For number 4, the height is 7. Radius 6,400, radius 6,400, height is 7, D we don't know. I am going to redraw that triangle. What do we know about this angle right here? Since this is tangent, it is perpendicular, so we do have a right angle. 6,400, D we don't know. What's the length of the hypotenuse if the radius is 6,400 and the height is 7? 6,407. All right, and I'll let you finish the rest from here. I'll start you off. A squared, 6,400, plus B squared, which is labeled D in this case, equals C squared, 6,407 squared. And then you have one just like what we did in notes with big numbers, but we can handle them. We just plug them in our calculator, square, square, subtract, and square root. And you can finish the rest on your own. I will tell you this right here, 6, you will need to do some conversion, because kilometers, meters, you can't put meters when you're working with kilometers. So you'll have to change this to a kilometer in order to do the work. All right. Skipping number 7, it's already crossed out for you. 8, 9, and 10 are just like the ones we did in notes, where we used A squared plus B squared equals C squared, C being your largest side. If it does work, it is a tangent line. If it doesn't work, it is not a tangent line. Determine whether a tangent line is shown in each diagram. A squared plus B squared equals C squared. A squared plus B squared equals C squared. A, B, C. Now, do you see where it looks like, how can you tell where your right angle is in this picture? It is kind of hard to tell. It's always with the tangent. Here's your tangent and here's your radius. So this here would be your possible 90, which means 10 is the hypotenuse. You can also tell that because 10 is bigger than 8 and 6. Now we don't know that it's a hypotenuse, but it's the possible hypotenuse. This number is hard to read. That is a 7. You can make that correction right now. All right, flip your packet inside. These here you can do on your own. We know 15 is equal here, 15. 9 is equal here, 9 and 9. And 22 is congruent here, 22. 22 and 22, 9 and 9, 15 and 15. Same thing here, and add them all up. I do want to talk a little about 13. I want to let you read it to yourself first. Okay, I want to give you a few seconds to think about how to do this one on your own. If you were given this problem on a test, how would you go about finding x if they gave you that the perimeter is 76? Okay, we are listening. If this is 25, does everyone agree that they're both equal? This is 25 as well. And if this is 5, then this is 5 as well. And if this is x, then this is x as well. And now that I have every side labeled, I can make an equation. X plus 5 plus 5 plus 25 plus 25 equals the perimeter, and they actually gave us the perimeter is 76. X plus 5 plus 5 plus 25 equals 76. Just a quick reminder here that x plus x is not x squared, it is 2x. And I'll let you finish from there. 2x plus, add them up, subtract, divide, and find the value of x. All right, I want you to continue working. You can help the person sitting around you, but you're not getting out of your seats, you're not pulling out your phones, you are using this time to work.